Constellations is a lovely play about love and romance and string theory. And I don't know about you, but I am not a scientist. So to understand more, we're going to go to the Adventure Science Center and speak with its planetarium manager, Derek Roll.
To get you. Come on. So string theory is where stuff starts to get a little goofy to talk about, just because it is all theory. I mean, almost everything in cosmology is theory, which is pretty neat, actually. One of my favorite things about the idea of a multiverse is we can't prove it wrong, right? It's so big that right now, since we can't disprove a multiverse, that concept is every bit as legitimate scientifically as having one universe. So to me, that's sort of this awesome, humbling thing when you think about, the vastness of space that's out there. We know that there's more beyond what we can see, right? Humans have this history of saying, well, the sun is up there, it moves across the sky, therefore it's going around us, the earth must be the center of the universe. Right. And of course, over time, we study things more and more, no, that's not the case. Now we're starting to wise up a little bit and know that, okay, our solar system or the Milky Way galaxy, none of those is the center of the universe, but it's the center of what we can see, right? So if you factor, light travels at the speed of light, nothing too surprising there. So light is traveling at this insane speed, right? We say that's the speed limit for the universe, right? And if light is traveling at that speed, then we can see light as long as that light has had time to reach us. So for us, that limit is 13.7 billion light years, right? You look 13.7, 13.8 billion years back, then we had the Big Bang. So that's the furthest light we can see. We're trying to get as close to that edge as we possibly can, but we know there's more out there. There's no reason for us to be, at the center of this. It's just the center of what we can see. So if it's one universe, we can see our little, bubble of that universe. If there are multiple universes, we can see our little bubble of wherever we are.
And it's entirely possible. We're just not able to know that yet.
Well, right, and it really is this, fascinating and humbling and frustrating, all in one limit of, we'd love to be able to see it all the way back to the very moment the Big Bang happened, but it's a limit. It's tough. So we try to get sort of the oldest light that we can see. We try to study. In recent years, there have been news about the confirmation of primordial gravitational waves, and actually looking at that light, some of this very, very, very old distant light, if you will, if you think about how far out we're looking. They start to see these little fluctuations in it. When you see those fluctuations, that confirms that we do have gravitational waves. You then combine that with last year's news of actually detecting the gravitational waves and actually detecting one here on Earth. So the LIGO experiment, if you've heard of that, they actually built 2 detectors with these massive, sort of right angle arms that extend for kilometers. They built 2 of them. They were calibrating it. This is my favorite thing. I was actually talking to one of the scientists who worked on the project, and what he did is basically they were setting up the equipment. They weren't even ready to start the experiments, but they were doing some engineering tests, making sure they could turn the whole thing on, and they detected the collision of 2 black holes.
What?
And this is this crazy, crazy thing. They've got all these emails, and they said, hey, there's a very, very interesting event that just happened, and to the whole team. Everyone go look at it. And so they put it out there, and they checked, and they had hundreds of people doing error checking. To set up an experiment of this scale, they would put in false positives. And so they spent a huge amount of time checking every step of the way, making sure no one added in a test to see how the scientists would handle it. Turns out no one did. Not too far after, they detected another one, and there's actually a third one that you don't hear about quite as much. It's not quite as clean data-wise, which could mean it's a little bit further away in the universe, so we don't get as strong of a signal on these detectors, but it's about 90% certain. So some people are saying that we have detected 2.9 collisions of black holes.
So what does that add to our knowledge that we have detected those?
So this is helping us to understand how things work just on the huge, huge scale of the universe, right? We don't have a very sort of long-standing understanding of gravity. You look back to Isaac Newton, that's a very basic, we still use his understanding of gravity for most things. If I pick something up and drop it here on Earth, that motion is still described really, really well by Isaac Newton's work. Now you look out in space, things are a little bit bigger, you've got sort of a different environment out there, and space is mostly dark. It's pretty hard for us to understand. So we're understanding actually how the universe itself works, sort of lives and breathes, if you will. And gravitational waves are one of our new tools to figure that out.
I see. So one of the lines in the play is about how when you're looking at the quantum realm,
That gravity is pretty much insignificant. But in terms of relativity, it's vital. Does that sound right? Is that kosher to you?
and if so, what does that mean? Because one of the points that the play is making is that then you've got string theory, which is bridging these two ideas.
It's a way to sort of wrap our brains around the two ideas, and that expands into the possibility of a multiverse.
Mm-hmm. And yeah, so the idea with string theory is to try to sort of unite everything, right? We have all these different types of particles out there. You've got photons for light. You can go on and on with all the different particles we've got. Mm-hmm. The idea with string theory is to find a way to unite and have actually something, I don't want to say weaving together with string theory, we'll avoid that, but something to really unite all these different particles. Not to treat them as the same thing, but to have one lens that actually can connect them all, to really help sort of unify lots of different ideas that we have out there, right? We've studied things on a small scale really, really well, and we've talked about studying things on a huge scale. Both of those things are really important, and we're still learning things on both ends of the scale. And so the idea to actually connect that so that we could have one theory that, to rule them all, if you will, that is definitely something exciting, but it's a huge task. I mean,
because really what you're seeing at this level and what you're seeing at this level don't always coincide, right?
They don't always coincide, and yet there are still certain pieces that do weave between.
String.
Yeah, so if you can find a way that actually connects them and something that works on the big scale and works on the small scale, that's going to be a pretty amazing theory if we can get there. And that's what's so neat about theoretical science. I don't even want to just say astronomy or cosmology, because there's so many different sides to this theory, and math comes into it so much. And so got a little bit of astronomy, cosmology, physics, math, and I'm sure I'm missing
right.
a whole bunch more.
They're not as important.
I might be a little bit partial to space when
right.
I get to play around in here all day.
So do you think there's a multiverse?
I don't know. I think the idea that we talked about earlier, where the concept of a multiverse is as valid as a single universe, I sort of got stuck there, and I thought, why run all the way down one path if it's as valid as any other right now? Right. So I think for simplicity, I might lean toward one universe. But I don't want to put all my eggs in that basket, because as a scientist, I think considering theories until they're disproven is a little bit of what we're supposed to be doing.
Do you ever find that you live your life slightly differently, thinking, well, maybe there's a multiverse, so I can go down this road, but if it's the wrong choice, then there's another universe where I'm making a different choice and it's better?
I think sometimes I am guilty of being a little too human and just sort of staying stuck right here on Earth. I think in that aspect I'm probably more partial to the one universe, but part of that
bias, scientific bias.
There we go, little bit of bias, but I'll own up to it. Yeah.
This is an undercover investigation.
There we go.